How does brain plasticity compensate for silent strokes? Imagine your brain as a bustling city with roads and highways connecting different neighborhoods. When a small part of the city experiences a silent stroke, it's like a minor roadblock that doesn't cause immediate traffic jams but can cause issues over time. Luckily, your brain has a remarkable ability called neuroplasticity that helps it adapt and keep things running smoothly. This process involves the brain reorganizing itself by strengthening existing connections or creating new ones. For example, if a silent stroke damages areas responsible for movement, nearby regions or even the opposite side of the brain can step in to take over those functions. This is called reorganization of neural circuits, where dendrites, the branches of neurons that receive signals, grow and form new synapses or connections, helping to bypass the damaged area. The brain also promotes the sprouting of new axons, which are the long fibers that carry signals between neurons, and encourages the formation of new synapses. This growth helps rebuild pathways that were disrupted by the silent stroke, allowing the brain to maintain or regain functions like speech, coordination, or memory. In addition, the brain can recruit regions adjacent to the infarcted area, known as peri-infarct regions, or even activate the opposite hemisphere, called the contralesional side, to compensate for lost abilities. This shift in how the brain maps functions to different areas is a key part of recovery. Supporting these changes are molecules like growth proteins that promote nerve growth and synapse formation. Neurons that are more excitable or adaptable are often incorporated into new circuits, further aiding recovery. This plasticity also underpins behavioral adaptations, meaning that with targeted training or therapy, individuals can relearn skills or improve functions that were affected by the silent stroke. For example, practicing movements or cognitive exercises can help reinforce these new neural pathways. However, plasticity is not unlimited. The brain's natural inhibitory mechanisms prevent excessive or harmful growth, maintaining a delicate balance. This means that recovery can vary widely among individuals depending on the extent of damage and the brain's capacity to reorganize. In summary, brain plasticity acts like a flexible network that rewires itself after silent strokes, forming new connections, recruiting different brain areas, and supporting relearning. This adaptive process helps preserve brain function and can be enhanced through rehabilitation strategies. Always remember, if you suspect a silent stroke or experience any neurological symptoms, consulting a healthcare professional is essential for personalized care and guidance.